Hi, everybody. Welcome to day 4 of our events for Hack the Orb. Really happy to see a lot of you making a ton of progress on your projects. And we've got 2 great presentations for you today. So the first is Patrick from Chainlink is coming in to help get set up specifically with a Chainlink Oracle in Agoric. So we'll go through some details on that. And as always, we'll be monitoring for questions both in YouTube and in Discord. So if things come in, I can break in, ask Patrick to address them, and we can talk through. And then after that, Kate Sills is going to be coming on to talk about the loan contract that she built in Agoric. So that'll be a really important presentation as well as we start to show you a little bit more of our DeFi implementations. Yesterday, again, was the call spread detail. Today's loan contract. So 2 great ones today. And with that, I'm going to bring Patrick on.
Hello. Thanks so much, Roland. Thanks for having me, everybody. All right, so am I sharing screen? Am I good on the okay, cool. All right, so we will be taking questions. We want this to be a more of a conversation-y type demo here. I won't be able to see the comments because they are going to be on this other tab here. So if you have a question, Roland will ping me, but feel free to ask questions here. So what we're going to be demoing today is how to use a Chainlink Oracle on the Agoric chain. So we're going to be doing a couple things here. We're going to be accomplishing a couple things. We're going to be spinning up, spinning up our local Agoric chain, attaching a Chainlink node to it, and then we will be sending a query. Sending a query from the Agoric chain to our Chainlink Oracle and having that actually return the result back on chain. So everything that we're going to be doing and everything that you need to know is in this repo. So actually, let me drop this in the chat. Watch out for the recursiveness for a second here, or private chat, I guess. But yeah, this will have everything here. And the great part of this repo is that everything that you need to know is in the README. And you can literally follow along step by step. And, those are the READMEs that I love. So for those of you who are a little bit unfamiliar with Chainlink and how kind of Chainlink works. So Chainlink is a blockchain agnostic Oracle, which allows people to bring data on chain. And in particular, it also allows for decentralized data because you can have a network of independent Chainlink Oracles come together, provide reliable data on chain so that your smart contracts can stay trustless, which is really, really important. And then if you didn't see my presentation yesterday, go take a look at it. It has some really, really good information. And this is what a lot of the top DeFi projects are using right now. Aave, Synthetic, Yearn, they're all using Chainlink to get price feed data because Chainlink is so reliable, so secure, and decentralized. And it's really easy to work with too. So the way that Chainlink works, and again, if you haven't watched any of the video yesterday, definitely go check it out. But the way Chainlink works is these off-chain oracles are going to be reading the chain, looking for requests. Reading the logs of the chain, looking for requests. Once it finds one, it grabs the request, does whatever the request tells it to do, and then it returns the data on chain. The way that it does this and the way that Chainlink works with any chain is you just need these 3 pieces to customize your Chainlink node to work with any additional chain. You need an external initiator, which tells the Chainlink node, when to kick off. And it also defines how to monitor the chain and what to look for when reading the chain. You have an external adapter, which can do a number of stuff, including getting customized data, but for customized chains in particular, it can also define sending results back to the chain. So the external adapter for this one, for this demo, shows how to write back to the Agoric chain. The external initiator here shows how to read from the Agoric chain. You also need the link token, which secures the Oracle network. We're going to be testing, doing it for free. Obviously, in a production system, you don't want to do that because then you have no economic incentive for nodes to stay honest. Anyways, so here's the repo. It's established a generic way to interact with oracles such as Chainlink. Here are the basic pieces, and we're going to be going to this Chainlink Agoric subdirectory to get started with the Chainlink nodes here. And we're literally going to follow it step by step. So prerequisites, you're going to want to install these Docker, JQ, Yarn, Node.js. Each of these links go to a site to actually install them. Then you're going to want to set up the Agoric command in your shell. So if you haven't, let me zoom in here. Actually, is that going to ruin my zoom for everything? Oh, no, it's not. If you haven't gone through this, take a minute to go through it, and then let me. It's just a couple of. Excuse me. You're going to be downloading this Agoric SDK here. I'm not going to be going through it exactly. I'm just going to kind of show you what it's going to look like. Go through this Agoric SDK. Clone this Agoric SDK. Yarn install, Yarn build, and then you want to link it and install the CLI. So I ran this Yarn link CLI, user local bin Agoric, and now in my user local bin, now my user local bin, I have this Agoric command. So now I can run. I'm not going to run it, but I can run now I can run the Agoric CLI. So this is the first page that you have to do to do anything with Agoric. You don't have to go to this starting a project page. If you want to, if you want to run through this starting project, you absolutely can. But we're gonna do some special stuff and basically to run our local chain that isn't in here. So. Cool. So once we get all this set up, we can keep going. The Chainlink components, blah, blah, blah. Great. So now we want to start our local chain. So we have our Agoric SDK installed. Now we actually want to start it up. Can I minimize this? Let's maximize this. Yeah, and let's minimize this. Although you can see my stuff in the background, whatever. Sorry. So we're gonna be in this excuse me. We're gonna go to this DApp Oracle repo. We're gonna run Agoric install, and this will install all the dependencies that are listed in this repo. It's great, done installing, and then we're gonna run this command. So this is actually going to start the local chain implementation. We're going to run it in the background and output. For those of you who are a little bit unfamiliar with the commands here, we're going to output it to chain.log. So this is actually going to set up a job in the background. So if we go to jobs, we can see it right here. And what this is doing is it's actually setting up our local chain, and it's going to do that in a Docker container. So now we can see Docker PS. We can see here's our local chain running, and we can even tail. We can even tail the log here, and we're seeing all the logging of this Docker image, which is running our local chain. So we're just going to wait for everything to kind of finish getting spun up. And once it gets finished spinning up, we can actually continue on. But another way we can look at this, it looks like it might actually be done, is we can do Docker. We can do it through Docker. We can do Docker logs. And then the container ID, and then we can see, here's the logs. And once you start seeing, executed block, committed state, that's how we know that the chain is actually running. So Docker logs and Docker tail chain.log are both ways we can actually, wait to see that it's done. So cool. So once it's done, we just move to the next step. So now we're going to set up a Chainlink node, an external adapter, and an external initiator. So this is the Chainlink node, which is going to be the off-chain service that is going to be doing this pushing and pulling. We also have to set up an external adapter and external initiator. So these are services as well. These are APIs basically that are going to be defining how to read and write to and from the Agoric chain. So we have everything set up in this wonderful .setup script. So we're just going to go to the Chainlink Agoric. But here, if you want to look at what the setup script is doing, you absolutely can. But basically, it's going to set up those Docker containers for us, being namely the Chainlink node, external initiator, and external adapter. You can, if you want to do all this stuff manually, and then it's going to pull the Docker images. Some of them already have. I'll show you in a second how to look at those. But if you don't want to use the setup script and you want to run through this whole thing manually, just so you can learn exactly how to set up external initiators, maybe you want to do something a little bit more intricate, you can check out the Conflux Chainlink integration video that we did recently. That has a different setup than this. This one is this one's kind of a little bit nicer because you have ./setup and you just run through everything. But that one's more granular, and you can see behind the scenes exactly what's happening, exactly what this setup script is doing. So great, so cool. So we have so we're setting up. We also have to set up a Postgres node, Chainlink, and it's doing it so fast I can't even talk about what it's doing. So it's setting, it's creating these Docker images, and it's we're adding like a solo instance of the chain, a Postgres database for our Chainlink node, the Chainlink node itself, and the Chainlink adapter here. And I'm looking for the external adapter, and maybe that's defined later or something. I forget actually, but we're setting up these. And actually, if we create a new tab, we can do Docker PS. We can see kind of all the new containers we have. We have our Chainlink adapter. We have our Chainlink node. We have this swing set solo. I believe this is the Agoric, like a solo implementation. This is our Postgres database, and then this is the Agoric SDK chain. Anyway, so we have all these up, and we can see if everything's working correctly by just like quickly looking in the logs of like our Chainlink. And great, we can see that it's spinning up the UI here. It looks like it logged in fine, which is great. Cool. So because of that, at this point we can actually log in to the UI. So, and it's running on here, or this place is running. So we should be able to log into the UI. And the password is not real. I forget what the username and password is. I'm skipping around a little bit, but if you want to follow the README exactly, you can. Not real. Not real at fakeemail.ch, and the password is 2 chains. So cool. So we're logged in. We're gonna go back. We're gonna stay in order of the README though. Setting it up is going to take a couple more minutes here. We're actually deploying. We're deploying some smart contracts, some Agoric smart contracts, which is really cool. Also defined in the setup script so that we can work with our Chainlink node. So we're deploying some of these Oracle contracts already. And while it's deploying, just a couple of other tidbits. If you're running an Agoric chain externally, you can run something like this. Again, we're running a local Agoric chain, so we don't have to run this. And we're actually only running one Chainlink node. If you want to test multiple Chainlink nodes, this actually is going to give us an output in a second saying, hey, do you want to do 2 and 3? We're just going to work with one. If you want to test the decentrality and sending to different Chainlink nodes, you can absolutely spin up as many as you want. And we encourage you to do so once you've gotten down working with one. But working with one is perfect enough at the beginning. But once it's done, it's going to spit out some information for us that we're going to need. So we're just going to give it a hot minute to finish setting up, and it looks like it's creating the external Oracle contract on our Chainlink node number 1. Hopefully everybody can see this. And actually, we do have a hot minute here, so I'm going to flip this. Oh, no comments yet. Okay, cool. You got to see a little bit of that recursiveness. Great. I love seeing success in all caps on on logs. So the contracts is up. Great. We've got our board. So board IDs in Agoric are kind of like addresses in Ethereum. Now we're adding our external initiator, and we're running our external initiators. Would we like to start oracles 2 and 3? No. Okay, great. Now everything is set up, and we're going to need these keywords, these passwords, these variables, basically, in a minute. But if you forget them, you can run this node show jobs.js, and it'll just pop them back up for you. So cool. So awesome. So everything should be set up with this wonderful /setup script. That's really nice. So again, now we can sign into the node. We are already signed in here. We have a good chunk of nothing, which is great because we have a blank Postgres database. And excuse me. Oh yeah, and if you want to start and stop them, I'm even going to do that right now. We can do Docker compose down. This is actually going to close everything. It just takes a minute for it to close. And to do this Docker compose down, you have to be in the correct directory here. And if we refresh, it's going to kick us out. And then we just run Docker compose up. Once we already have everything set up, and it should just allow us to get back in here. Oh wait, yeah, it's running everything in the foreground. Sorry. I just canceled it out. Docker goes up. Oh wait, it's still gonna start all of our stuff. Okay. We're just gonna do it in a new tab. Yes. Chainlink adapter, Chainlink adapter. And we should be able to log back in now. Great, we're able to log back in. Cool. I'm just gonna let that run in the on the other tab here. We're just gonna let that run there. Cool. So we're gonna do show node show jobs.js again, and then we have all our board ID stuff here. Great. Now we want to start up the UI. So this is actually going to be the Agoric UI. The Chainlink UI is already up, as we can see, and it's working perfectly. So we're just going to run this. It's going to yarn start. We're going to go down a directory, and yeah, we're going to build it, and then we're going to go here and see our UI. So it's a really simple UI, and then actually I think I have to change it. Yeah, I'm going to change this in a second. It's a really simple UI, but it's going to give us all the pieces that we need to actually start running Agoric Chainlink API calls. So we do have to add a couple of pieces to this URL. Like we said, we got this. We got these variables from our show job node, show jobs.js, and we actually have to add these to our. We have to add these to our Agoric UI here. So your UI is actually going to be localhost 3000 $API URL equals backend API URL. So we got it as this, I believe. Am I doing that right? Oh, yeah. I think I'm not doing that right. Here. Yeah, localhost 3000 API URL equals the backend API. I know that that's the same thing. Typing it in right? API URL equals backend API. I think I might have messed something up with the Docker Compose. Let's actually just kill it real quick. Sorry, guys. It's running all three. Sorry, I might have messed something up with the Docker Compose there. Whoops. Docker Compose -v. We're just gonna do the setup again. Sorry about that, guys. Yeah, I think I messed something up with the Docker Compose, but yeah, it'll kick us out now. Or maybe it's already up. Yeah, it's already up. So, anyways, basically what we're gonna happen then is we're gonna log into the UI, and then we're going to call an API and make an API call, and then we'll be able to see it on our Chainlink Oracle here. And then let's sign back in. 2 chains. Great. And for those of you who are a little bit unfamiliar with the Chainlink UI, Wallace is setting up. What we're going to see here is every job run that comes through. It's going to be in this run tab, and all the jobs that we define are going to be in here. So fill the job. Chainlink Oracle. Yeah, all the jobs we define are going to be in here. And let's just wait for this to finish. Oh, wow, it's done now. Okay, cool. So the reason it wasn't working is reason I knew it wasn't working is because we couldn't see this query Oracle button. But it looks like it's all done. Nice. But we're still deploying. We're still deploying the Oracle contract, so we're still going to give it a second. But yeah, once everything's deployed, we'll be able to pull our Chainlink node. So we're just going to make API calls to our Chainlink node, so we can just kind of hang out for a little bit while this redeploys. It looks like stuff is working correctly. Yeah, let me look at no questions. Yeah, if you guys have questions, feel free to pop in. I know we have this gross recursive window at the moment.
We did have one question come in through a separate channel.
Yeah, sure.
And I know you may have spoken about this a little bit in a previous presentation, but do you have ideas around what good uses of oracles people could make as part of the hackathon, and what are your thoughts there? Yeah,
I mean, so an easy answer is to just look at DeFi Pulse. I mean, DeFi Pulse, Agoric is a chain, especially that's specifically powered for DeFi, which is great. A number of these top projects are using Chainlink oracles to do pretty much everything. Aave, in order to get pricing data, it's using Chainlink price feeds. Synthetics, same thing, using Chainlink price feeds. Finance, Chainlink price feeds. I don't want to say anybody who's not using a set protocol. Same with Chainlink price feeds. I believe Bancor is, Loopring is, BZX. I mean, getting pricing data is kind of one of the easiest kind of like low entry, let's get pricing data, but you can build really, really powerful applications with it. Other than that, I mean, you can kind of do whatever you want. Chainlink oracles allow you to do any type of API call, get any data, read any chain, read any external source, really do whatever you want. So that being said, the sky's really the limit with what you want to do. We have a blog out called 44 blog ideas Chainlink. Brave game money. 44 ways to enhance your smart contract with Chainlink, and it's literally just a list of ideas for hackathons. So if you haven't checked it out, be sure to check it out. It'll give you some really good ideas here. So anyways, let's go back here. All right, back here. Looks like we're just about done setting up. Once it finishes setting up, we'll run through that show jobs. We'll run through that show jobs. It's adding our external initiator. It's adding our job spec. No. So, okay, cool. So now, if we go to our dashboard, we go to our jobs, there should be one in here. Perfect. There is. And you can kind of use this format to define the rest of your jobs. But again, it's a combination of initiators and tasks. So we have our external initiator, which is we've named test EI, but this is the initiator that's reading from the agoric chain that we've set up. But then it's going to make an HTTP GET call, JSON parse, which chooses the correct key that you want, multiply it, and this agoric adapter or task is actually going to post your data back on chain. So again, we can just follow right with the README. So we're here. Great. We're at the right place. And we're going to submit our query now. So we can submit our query by, again, grabbing that node show jobs.js. And our board ID is going to be this. Take that. We're going to pop it in our board here. Oops. This is going to help us choose the Chainlink Oracle that we just spun up. And now this is an example of the syntax they're going to use building your agoric smart contract to make the API call. You can see the parameters here. We're going to change the job ID to this job ID. And it should be the same job ID of this one. And in fact, it is. So basically we're saying, hey, we want to grab the Oracle from this board that has this job ID, and here are the parameters that we're going to give it. So if we query Oracle, we should see in our runs a new run, and it actually completed super fast. So we didn't even get a chance to kind of like look at what it was doing. But it has all the JSON of what went through. And basically what happened was it picked up our job. It picked up our job here with the external initiator. It made this API call that we defined here. And then we don't have enough time to kind of make other fun ones, but it made this API call, and it parsed the JSON down just to this value here, this last value, multiplied it to get rid of all the decimals, and then it posted it back to the agoric chain. And we can see the results of the query over here. And that's really it. That's the most basic use case. We can do, more fun things. Let's, because we have like 2 minutes left here. Let me just, if you want to just kind of play with it and see some of the other stuff you can do. Let's do duplicate here, HTTP GET, JSON parse. We could do.
Patrick, by the way, if you need to run long to do a couple extra commands, we checked internally. That's totally fine.
Okay. Yeah. Let's do something a little bit creative here. Let's do a. I don't have that parameter enabled here. Let's do. Yeah, maybe we won't do something that creative. But what we can do, we can even like grab some of these parameters and put it in here. So we're going to do parameters are going to be times. And we'll do, we're going to make it a massive number. I hope that this doesn't like break agoric. Body must be defined. Oh, that's right. You have to define the body. Okay, so we're not going to do something creative here. This parameter actually has a body parameter that's in the database that you have to define with it. It doesn't show up in the UI when you duplicate it though. So maybe we won't do something creative here, but you can look at that job spec. Actually, let's find out where to get that job spec. You can look at that job spec in one of these internal setup scripts. Where does it add the job spec? Add job spec. Aha. Here we go. Here's that body endpoint. So we would just have to add this to make our new job. Oh yeah, we could actually add it. Just copy this whole thing and plop it in. But then you can add more interesting things here. You can add parameters to HTTP GET, JSON parse, multiply, whatever you want. Just make sure you add this body section in here. And yeah, so that's pretty much it. That's yeah. And then now that you have a way to interact with APIs, you can do whatever you want. A lot of people, what they do is sometimes they make their own APIs to do custom things. And your smart contract is now connected to literally anything. Excuse me, literally anything that you want. So I'm gonna stop sharing screen here. It looks like there are no questions, but we're in the Discord, actively monitoring the Discord. Excited to see what you guys build here. Now that we've walked through this demo, you now know that you can pull these APIs in. You can do whatever you want with your Agoric smart contract. Really excited to see what everyone builds here, and we'll talk to you soon. Roland, do you want me to close out, or you're
all right? Yeah, no, thanks
right,
a bunch,
cool.
Patrick. This is a great presentation, and for those of you that are going to watch asynchronously, as Patrick mentioned, we are in the Discord this week, next week, so we'll be answering questions. So excited to have everybody get set up, and Patrick, thank you again for coming out to support us here.
Absolutely, thank you for having me.
All right, see ya.
Bye, guys.
All right, and we are just going to keep on rolling here. I think the next presentation that we've got is Kate Sills coming back to talk us through the loan contract that she built in Agoric. So you may remember she gave a presentation, I believe, on Saturday, going through the fungible token faucet and the baseball card DApp store that she, I think, built in a day each. And now the loan contract, which was a little bit more complex on her side, but she'll be taking us through the components there, and I'm just going to bring her on now. Hey, Kate.
Hi. All right. Let's go ahead and get started then. So hi, everyone. Today we are going to be building a basic loan contract. So you might be familiar with MakerDAO and their vaults. This is a bit similar to that. But this is just going to be the very basics. All right. So as always, we'll be taking questions on YouTube Live and Discord. If you're watching this afterwards, feel free to still ask questions. So just to go over a bit of the loan process. So what's going to be happening is that the lender is going to be creating a contract instance. The lender then escrows the maximum loan amount, and the borrower adds collateral and takes out a loan. So that's pretty simple. And then the loan. Yeah.
Kate, really quick, you're not sharing your screen if you're intending to. So let me.
Oh. Right, let's fix that. All right. Sorry about that. Let's go back. Okay, so feel free to join us on Discord and explained a little bit about the loan process. And then this loan is ongoing until the borrower repays the loan entirely, plus interest, and gets collateral back, or the value of the collateral falls, triggering the liquidation of the collateral. So it's sold for money, which is given to the lender. So to protect against liquidation, the borrower can add more collateral. And this raises the ratio of value of collateral to the loan amount. Okay, so this is the basic loan. So there's some to-dos that we hope to do in the future that would make this a lot more complex and usable. So for instance, if the value of the collateral goes up, then you might have excess collateral that you might want to put to other uses. So you might want to withdraw your excess collateral. You also might want to repay partially. Most loans you're able to repay partially, right? So it's a bit silly to only be able to repay at the end when you have all this compounding interest. And then also on the lender and the contract side, the contract might want to liquidate partially, so that if the value of the collateral goes down, it's not the end of the contract. The contract liquidates enough to continue. All right, so there's just a few things that I want to explain before we actually get into the code. So first I want to explain about Zoe installations and instances. So this is a little tricky, but it's actually a very cool feature of Zoe. So an installation is bundled code installed on Zoe, and it's given a unique identifier. So instead of it just being a contract address that determines what code is running where, in Zoe, each running instance actually has an installation, has an identifier for that particular code. And the instance is the running version of the code that a user interacts with. So you can create many instances from the same installation. And the really cool feature of this is that you can compare installations to see if a contract is running code that you've audited previously. So you don't have to use the hash of the code to be able to try to figure out if any alterations have happened. I also want to go over the offer lifestyle. So if you're interacting with a contract, the first thing that's going to happen is you're going to receive a Zoe invitation, and then you're going to use this invitation to make an offer with Zoe. And once you make an offer, Zoe returns a seat, which represents basically your ongoing role in the contract, your ongoing position in the contract. And when you make that offer, the associated offer handler is called. And this is code within the contract that the contract sets up that's associated with that invitation, associated with that offer that gets called. And we'll see this when we get into the contract. So the seat that you get from Zoe, it has methods that return promises for results. And there are two types of results. One is a result that you get directly from the contract, directly from the results of the offer handler. And that's the offer result. So there's a method get offer result. And then there's there's two methods actually to get payouts from Zoe. And these payouts are the actual digital assets. So the offer result is often used to return a string or return an object or something like that. The actual payments, because Zoe is able to enforce offer safety and conservation of rights and payout liveness, those payouts should come from Zoe, and that's those methods are how you get them. Okay, I want to explain a little bit about a Zoe invitation. And so it itself is an ERTP payment for a non-fungible digital asset. And that asset is the right to join a contract in the particular role defined by the invitation. So these invitations are payments minted within Zoe, and they can be validated or claimed using the public Zoe invitation issuer. And to use them, you use them to make an offer, and they're consumed in that call. So when you call Zoe.offer with the invitation, that invitation actually gets burned, but during the burning process, Zoe validates that it's a correct invitation for a particular contract. And the really, really cool thing is that this invitation can be traded on in any generic Zoe contract. So if you already have an auction set up or an exchange set up or anything that can take ERTP digital assets, they can take Zoe invitations. So that's what we call kind of the higher order composability of the Agoric platform. So an invitation to a contract can be bought and sold, which is really cool. All right, so we talked a little bit about seats, but I want to go into depth on that. A seat represents an active offer within Zoe, and it has two facets. So there's the ZCF facet, the ZCF seat, which is the argument to an offer handler in the contract code, and we'll see exactly how this happens later. And then there is the user seat, the seat that we were talking about earlier, which is what the user gets as the result of calling Zoe offer. So the user seat is how the user gets their payouts and that sort of thing. The ZCF seat is how the contract does the reallocations and exits the seat. Okay, so this loan contract is going to use a price authority, which is something that is new with our work with Chainlink. So a price authority is a high-level API within the Agoric platform for an oracle, and it has a particular issuer for making credible quotes. So we're going to use two methods on the price authority. We're going to use a quote given, which you pass in the amount that you want the quote for and the brand in which you want the quote. So for instance, I'll be passing in an amount that represents all of the collateral within the loan. And then I want the value of the collateral in the brand that the loan is. So in the money brand, essentially. And we're also going to be using a quote when less than, or quote when LT. And that, as we'll get into later, returns a promise for a quote that will trigger when the value of the collateral goes below a certain trigger amount. So both of these methods, eventually, they return promises, but they return a price quote, which is a record that includes a quote amount and a quote payment. So in the future, we don't have this worked out entirely yet, or coded entirely yet. But in the future, you'll be able to use this quote payment as proof to others that a quote was given, which is very cool. Okay, so if you're following along, we're going to be looking at the loan contract within Agoric SDK. It's under the Zoe package. So you go to Zoe, source, contracts, and then loan. All right, so let's start diving into the contract. So the terms, first there's the MMR term, which is the maintenance margin requirement. This is the percentage of collateral compared to the loan amount. So for instance, we might require that there is 150% of collateral value compared to the loan amount. There is the price authority, which we saw earlier, and that is used for setting the liquidation triggers, among other things. We're also going to take in an auto swap instance. So auto swap is our constant product AMM, so similar to Uniswap. And we're going to actually be using that for selling or liquidating the collateral, if it comes to that. We're also going to take in a period async iterable. So an async iterable, this is actually a concept from JavaScript. And we're going to be using this for knowing when a period has passed and when interest should be added. So async iterable will be pushing values, basically telling us when that period, maybe it's a block height, maybe it's a year. It's really up to the whoever is passing in the terms to this contract. It's telling us when the interest should actually be calculated. And the interest rate, that's the rate in basis points that will be multiplied with the debt on every period. Okay, so let's go ahead and dive into the contract, but let me give a little bit of an overview. So it's a very lengthy contract. So each of the different parts of the contract have been divided up into different files. So we'll start with the index file, and then we'll go into the lend file, which is kind of the lender role. We'll go into the borrower role, and then we'll go into all of these different parts. So scheduling the liquidation, actually liquidating, adding collateral, closing the loan, things like that. Okay, so let's go over to the contract. So we are starting with the index file. There are a lot of comments here. I'll let you read those on your own. But essentially what we are doing in this file, we're checking that issuers for the collateral and for the loan brand have been determined. So this is telling the contract what kind of assets are going to be accepted as collateral and what kind of assets are going to be accepted as a loan. So when someone creates an instance of this, they'll create an issuer keyword record with both of these things defined. So we are just asserting that that is the case here. And rather than grabbing the terms each time that we use them, we're going to set some defaults and add them to a config. So, so you can see we set the default for the maintenance margin requirement to 150. And we check that these things have been defined, and then we add them to a config. So it's pretty simple. And then, as you've probably seen in some of our other contracts, we return a creator invitation here. So whoever creates an instance from this contract will get this invitation, and it's an invitation to lend money. So it's defined by this make lend invitation, which takes ZCF, which is the Zoe contract facet. So this is the side of Zoe that's exposed to contract code. And then it takes this config that we have defined. So let's actually go to that. So make lend invitation is defined in lend. All right. So let's go down to the bottom. So what's happening here is it's calling ZCF make invitation, with this function. And this function operates as the offer handler that we mentioned earlier. So when someone uses this lend invitation, this is the offer handler that will be triggered when they make their offer. So all offer handlers are passed the lender, or they're passed a seat, a ZCF seat. So this is, we talked about seats and how there are two different facets. So within the contract code, oops, my cat really wants to get in the video. Within the contract code, each offer handler is passed a ZCF seat. So in this case, it's going to be the lender seat because this is the lend offer handler. And there are a few restrictions on what the lender can do here. So because this is a loan and we may not be able to liquidate in time, perhaps the price of the collateral goes down much faster than we anticipate, and the value of the collateral goes to zero. We can't actually, let me see if I can get my cat out of here. We can't actually have the lender want anything here because no return can be guaranteed. Okay, but the lender is going to be giving a certain amount as the maximum of the loan. So they're going to be giving money in the loan brand that will eventually go to the borrower. They must have the exit rule on demand. And this means that at any time, they can take their money out. And the reason for that is that if they weren't able to do that, then their money would be locked up in the contract until the borrower decides to borrow. And if you're holding the borrower invitation, you might be able to lock up the lender's funds forever. So we don't want that to happen. So we're going to make it so that the lender is able to exit with their loan at any time before the money is borrowed. Okay, so what the lender gets back as the result of their offer is returned at the end of this offer handler. So they're actually going to get a invitation for the borrower. So let's go into how that is defined. So that's defined in borrow. And feel free to ask questions as I'm going along. A lot of this stuff is pretty complicated. It's a pretty complicated contract, but we've tried to divide it up into small pieces to actually make it easier to understand. All right, so this is probably the most complex part of this contract. Let's actually let's see. Let's start at the top on this one. So we know that this is going to return an invitation for the borrower. So you can see that we get our information from the config that's passed in. We can only lend what the lender has already escrowed. So the amount that the lender has escrowed, and this is how you get the amount allocated within Zoe. So Zoe escrows all of these goods and then represents them as amounts associated with seats. So the maximum loan that we can get is what the lender has allocated on their seat. So here's the offer handler for the borrow invitation. So this offer handler is just called borrow, and the ZCF seat is going to be the borrower seat, of course. So we just want to check first that the borrower seat is when the borrower makes their offer, they're going to be giving collateral and they're going to want the loan amount or a loan amount. So this is just kind of some bookkeeping. So we're going to get the amount of collateral that they gave. We're going to see how much of a loan they wanted. We're going to get the loan brand. So if you've gone through our ERTP guide, you might know this already, but the brand is kind of the identity of digital assets. So anything within the same purse or of the same issuer is going to have the same brand. And then we're also going to get the loan math, which is the amount math for the loan. So this will tell us how to add and subtract the loan amount. And we're going to get the collateral math. So one thing that's interesting here is that the collateral could be non-fungible. So you could be putting your CryptoKitties in here as collateral or your property title or whatever it is. So let's see. Okay, so here's one of the uses of the price authority. So we are going to ask for a quote in real time of if we were to sell all of the collateral that's given, how much of the loan amount would we get, or how much of the loan brand would we get? And so we get the collateral price in the loan brand here, and we want to ensure that it's greater than the amount that was required with the MMR parameter. So just for the error message, we're going to do an approximate calculation here, but we're not going to be using that for actually checking whether it's safe. The actual assertion multiplies the collateral price in the loan brand by 100 because we were doing percent, and it also multiplies the loan wanted value by the MMR, and then it checks that the collateral is greater than the amount that is required. So this certain details is specific to Agoric. You might have seen some similar patterns in Node and on other platforms, but this details allows you to put in information that is private for the consumer of this information. And so if it gets logged or something like that, it would likely not show up, but you would be able to see this in your console. Let's see. So we have a couple more asserts here. So we want to check that the collateral given has not changed after the await. So this is something that people may not realize. So every time that we do an await, we are effectively letting the execution go to something else and then come back. So while the execution has gone to something else, things might have changed. So we need to make sure that things are the same so that we can safely continue. So we need to assert that the collateral given has not changed. If it has changed, something very strange has happened, and we should probably throw an error. We also need to check that the loan wanted is less than the maximum loan that we can give. So that's just a basic check. All right, so given all of those checks, we can actually start doing the transfers. So as I said before, you escrow your digital assets with Zoe, and then the contract is able to reallocate those assets in terms of amounts. So within the internal record keeping of Zoe, the contracts are able to say, actually, this person should be getting this amount, and this person should be getting this amount, and so forth. But it's all conditional on those reallocations passing offer safety. So it can't violate what each individual offer still has to get either what they said they wanted or a full refund of what they put in. And it can't violate rights conservation. So if you're doing something and you miscalculate and suddenly you're dropping digital assets on the floor, Zoe won't let you do that. So here we're going to be using a helper called trade. And what trade allows you to do is to use kind of a more declarative language saying, I want to describe what the gains and losses are. And then under the hood, this helper is going to do all of the math for us to make that happen. So first, we are going to transfer the loan amount from the lender to this collateral seat that we make. So up here, we made an empty seat within the contract without having to make an offer. And we're going to use this for kind of a place to allocate things while the contract is going on. So first we're going to put the loan on there. So we're taking only the amount wanted and not the maximum loan. We're going to take that away from the lender and give it to the collateral seat. And we're able to do this partially because the lender seat did not specify what it wanted. So this still fulfills offer safety. All right, and then we are going to transfer all of the collateral to the collateral seat. And we are going to transfer the wanted loan amount to the borrower. So you can see the collateral seat gains the collateral, and it loses, and the borrower seat gains the amount of that was wanted of the loan. So then we exit the borrower seat so that the borrower gets their loan. But this isn't the end of everything for the borrower. They will actually, let's scroll all the way down here, they will be given as their offer result of this particular offer handler, they'll be given this facet that allows them to do a few things. They can close a loan, they can add collateral, and they can get a promise that resolves when liquidation occurs. And they can also get up-to-date information about what their current debt is. So if they choose to repay, they'll know how much needs to be repaid. All right, so let's scroll up a little bit and find out how we can do this. Okay, so there is another file that allows us to make a debt calculator. And it gives us back two things. It gives us back a function to get the current debt, and it gives us the notifier that I mentioned that allows the borrower to know up-to-date information about what they have to repay, how much interest has been accrued, that sort of thing. Okay, so let's hop into that. Notice that we pass in a special config for the debt calculator. So that is within update debt. All right, so this is a bit complex. Here we just have a basis point denominator. So if you're trying to translate a basis point out of the basis point notation, this is what you would use as the denominator. Let's see. So we made a call to make debt calculator with the config that we saw. So we got the original debt, which is just the loan wanted amount, but we're going to store that in an internal variable called debt that will be updated. So we also take in this period async iterable. And what we're going to do is we're going to have this period async iterable. Every time that it updates, it's going to call this update state function on our observer. So basically what we're doing is with this observe iteration, we are kind of registering this observer to be called every time that this async iterable pushes a new value through. So update state calls this update debt function. Finish, this probably won't happen, but in the case that the async iterable says that it's done, we'll also update the debt. And then if something fails, well, we're going to throw an error. And we are going to tell the user through this notifier that, hey, it failed. So let's go up to the update debt function. So each observer takes in a state. In this case, we don't care what the state is, because the period async iterable is just every time that it pushes any value at all, that's when we're going to be updating things. So we don't care what the value is. And what we do is that we calculate the interest using a function that is part of this config. We add the interest to the debt. We update the notifier for the user so that they know that their debt has been updated. And also we schedule liquidation as appropriate. So we'll go into this part a little bit later, but it's important to know that every time that the debt is updated, this changes the ratio of collateral to the debt. So we need to reschedule the liquidation to occur at the right time. All right, so we saw that there was this calc interest function here that was defined here. So this is kind of, we have this plumbed out most of the way to be able to use your own interest calculator. So what this is doing is just multiplying the interest rate by the debt and dividing by the basis point denominator, but you might have a more complex interest function. So from there, let's go back to borrow. Okay, so we saw how get debt is produced and how get debt notifier is produced. So the next thing that's going to happen is we're going to try to schedule the liquidation. So let's go into that. Oh, and throughout this contract, we pass this config around. And in this case, we add the collateral seat and the get debt function and a promise kit that the user here, they're able to get this promise, which will be resolved if liquidation does actually happen. So they're informed if liquidation happens, and we will pass that promise kit, the resolver and the promise, through to the liquidation function to resolve that promise when appropriate. All right, so let's see. So schedule liquidation, this is the part where we're actually using the price authority in a very interesting way. So all of this, we're just getting information from the config. We're getting the loan math again so that we can add and subtract loan values. We want to get the current debt. And what we're going to do here is we're going to calculate the liquidation trigger value. So this is basically when the value of the collateral equals the maintenance margin requirement % of the current debt. So we take the current debt value, we multiply by MMR, we divide by 100 because it's a %, and we get this value. So we use the price authority, and we call quote when less than or quote when LT with all of the collateral that is there. So all of the collateral is now on the collateral seat, so we just get the amount allocated. And then what we're saying is, please resolve this promise. We're asking the price authority, please resolve this promise when the value of the collateral goes below this particular value. And so we get this promise that we're going to call internal liquidation promise. So this is not what is exposed to the user. But when this resolves, we get a price quote. And as we saw earlier, a price quote, it has a quote amount and a quote payment. We're just going to use the quote amount here because we don't need to prove to anyone else that the quote was made by a credible source. We trust this price authority. And we're going to get the each quote amount has an amount in and an amount out. So what we want to check is that this quote is still pertinent. So the amount in would have been all of the collateral that was sold. So it may have been possible that we were scheduling several liquidation events. So maybe interest was added to the debt, maybe collateral was added. So we need to make adjustments. The way that we just kind of throw away the quotes that we don't need is to check whether the amount in of this quote is equal to the current collateral. If it's not, we do nothing. If it is, then we actually go ahead and liquidate. So this is where that promise that the user gets is resolved with the price quote. So the user is informed of the liquidation at this point, and then we actually liquidate. All right, so if one thing that's very important if you're doing asynchronous programming is to handle your errors appropriately. So here, if for whatever reason there's something wrong with this call, if the price authority isn't able to do this, then we log an error and we reallocate. So at this point, the borrower has exited with their loan, so we can't really do anything about the borrower. We can't take the loan back, but all of the collateral is still there. So we will give the lender their collateral, and we will shut down with failure. All right, so let's actually go to liquidate. Let's go down here. Okay, so for testing purposes, this is divided into two functions. But the liquidate call takes ZCF and the config as the pattern that we've kind of seen before. We use the auto swap instance object that we got in the terms to get the public facet. So a facet, as we talked about with the two facets for seats, is just a particular view of some larger entity. So contracts have a public facet, and then the creator invitation and the creator facets are other facets of that contract that are more private. So the public facet of AutoSwap, again, this is our constant product AMM, similar to Uniswap. This will actually allow us to perform the swap, to perform the sale of the liquidation, or of the collateral, the liquidation. Okay, so let's go back up here. We're going to actually perform the liquidation. So we get the Zoe service, we get the loan math, we get all of the collateral, or the amount of collateral that has been allocated to the collateral seat. And then what we do is we call this helper withdraw from seat to get the collateral in the form of a payment. And the reason why we want to do that is because we're going to act as a user. We're going to get an invitation from the AutoSwap public facet here to swap. And then we're actually going to make an offer with the proposal and the payments here. So we're going to say that our proposal is that we're going to give all of this collateral, the same amount as in the collateral payment here. And because our price authority is actually, it might be a different source than the AutoSwap instance, we're going to say that we don't want anything because the price may have moved or the price may have been different. And if we said that we wanted a certain amount, offer safety would prevent the transaction from going through. So at this point, we're saying we're going to sell it all. We don't care what the price is. We have a best guess of what it is, but we're going to sell it all regardless. So so we actually make that offer with the invitation that we make for ourselves from the public facet, the proposal that we make, the payments that we have withdrawn from the collateral seat, and we get a user seat in response. Okay, so let's go down to here. So that user seat, we will call get payouts, which gives us a promise for the payouts. And then we have a function that we will attach to that called handle payouts and shutdown. So that function is up here. So the payouts will be in the form of in and out. In will be the collateral payout, which hopefully we will have none of, and out will be the loan payout. We will also get the current amounts allocated. That'll just save us some time. And then as you can see, anytime that we do an await, it's a little bit dangerous because we are actually allowing other execution to occur while we're waiting. So we like to put this comment await just to make it very clear, because sometimes because everything's kind of in line, you can miss that something like that is happening. All right, so let's just create two new objects here that use the keywords associated with this contract rather than the AutoSwap contract. So AutoSwap puts things in terms of in and out. This contract, as we've seen, it has only two keywords, collateral and loan. So we're going to rename things. So the collateral amount gets the keyword collateral, loan amount gets the keyword loan. That's pretty self-explanatory. And then we're going to use this helper called deposit to seat. So we're going to take these payments and deposit them to the lender seat. Okay, so let's see. So let's go all the way down to here. So if this AutoSwap offer is not successful, then get offer result is going to throw. So we can handle this with two functions. One will be called if it resolves and if this promise resolves, and the other will be called if this promise rejects, or if this wasn't asynchronous, this would be throwing. So close successfully. We're going to exit the lender seat, exit the collateral seat, and then shut down the contract. So this call ZCF shutdown, it actually prevents any more offers from being made, and it actually shuts down the whole execution environment that this contract is in, so that the objects themselves no longer exist. And then if this promise rejects, if internally this throws, then we're going to close with failure. So we're going to kick out the seats, so they'll get an error message, and we're going to shut down with failure. Okay, so let's see. So we've gone over most of this. We've gone over the lender's position, the borrower's position. We've gone over the more complex parts of the borrower, so how the debt is updated, how the liquidation is scheduled with the price authority, how the liquidation actually occurs. So let's go into the two things that the borrower can do. The borrower can add collateral, and the borrower can repay and close. All right, so first let's go into add collateral. This is pretty simple. So if the borrower believes that a liquidation is imminent, they can add more collateral to prevent it. So essentially, the borrower is able to use the facet that they get to make an invitation to add collateral. That invitation has this particular offer handler called add collateral, which has gets the seat passed to it. So we're going to check that this offer is giving collateral, that it doesn't want anything, because remember, it's topping up a loan that already exists. So it can't want anything. It already has, the borrower already has the loan, and we're going to perform a trade. So we are going to say that the collateral seat will get all of the collateral from this offer, and the borrower who's adding the collateral gets nothing. And then we exit that particular seat for the borrower. And of course, now that the ratio of collateral to debt has changed, we need to reschedule the liquidation. And again, if this is an old quote, we're just going to drop it on the ground, because we do a check that the amount that's quoted is the current amount of collateral. All right, and then we return as the offer result just this string. Okay. So the other thing that the borrower can do, and let me actually go back to the borrower to show you where these things happen. So the borrower gets this result as the offer result of them borrowing the money, and so they're able to make add collateral invitation and make close loan invitation. So let's go into the code for the closing of the loan. So in the simple version, all of the debt must be repaid at once. So we don't allow for any kind of partial repayment. Okay, so let's go all the way down to the bottom here. So we're going to be making an invitation with Zoe. It's going to have this offer handler repay and close. Oh, and we don't want to put the amount of the debt to be repaid in the custom properties of this invitation. Oftentimes you can put custom information in a Zoe invitation to kind of say more about what the invitation will allow you to do, but we definitely don't want to put the current debt in that invitation because the debt will change over time. And that is why this is a function here rather than a particular value. We want to be able to get the most up-to-date debt. So in order to repay, let's check that the offer is being made correctly with this assert proposal shape. Let's check that they're actually giving the loan brand and that they want the collateral brand. This is just getting the loan math and the loan brand and the collateral brand again. We're going to get the amount that was repaid. So this repay seat that represents the borrower's position in this offer will have the current amount that they tried to repay. We're going to check that what has been repaid is greater than the debt, because we want all debt to be repaid. And then we are going to use the trade helper again to actually do the transfers after we've done these checks. So the repay seat, which represents what the borrower is doing right now, it will gain all of the collateral. And the collateral seat will temporarily get all of the loan. So the collateral seat inside the contract is kind of acting as the place that we place assets when we want to transfer them later. Then we will take that the loan amount that we put on the collateral seat and actually give it to the lender. So now the lender has been allocated their loan. And so after these two calls are done, we're in the position where no one has gotten their payouts yet, but within Zoe, the allocations that Zoe is allocating to these different seats are the right ones for us to exit. So at this point, the allocations have occurred, but no payouts. And then when we call exit, that's when those payouts occur. So the borrower gets their collateral back, all of their collateral. The lender gets all of the amount that was loaned back, and the collateral seat gets nothing, but it's just an internal seat for the contract, so that's fine. And we have a particular message that we're going to return, and we're going to shut down the contract. So that means, again, that no further offers can be made, and the actual execution environment, the VAT, is shut down such that there are no objects remain. All right, so that is effectively all of the contract. So we've gone through all of it. Let's see. So, oops. So there are some resources. There's a hackathon documentation. Oh, come on. There's a hackathon documentation. There's all of this code is within the Agoric SDK repository. And then we have a number of contract examples on our documentation site. So if there are any questions, I would love to take them now. Oh, and you actually get to see my cat at this point.
Hey, Kate. So no questions came in during the presentation, but as we've been saying, please do make sure to connect with us on Discord. We know a lot of you are watching this asynchronously, and we're here to answer any questions about any of the parts of the contract that Kate went through.
Cool. All right. Thank you, everyone.
Great. Thanks, Kate. All right, and that concludes our presentations for today. We've got a couple more for you tomorrow as well. As a reminder, we sent out a check-in email and a note on Discord for any teams that are, any people that have formed a team, any teams that are currently working on projects. Please fill out that check-in. That'll help us organize our own efforts internally to make sure judging goes well and we know who is going to be submitting to what prizes. It'll also help us connect you with a team or connect you with a project or help us help you work through project ideas. So we'll have another check-in come in on Friday, and that will be mandatory for anyone that is looking to submit to a prize. So be on the lookout for that as well. So as always, connect with us on Discord, connect with me personally. I'm Roland, the product manager. You can find me on Discord. You can find me via email. And we are excited to have more presentations tomorrow. Thanks a bunch.